Hello! Today we will focus on subtracting fractional numbers that have distinct denominators. It is crucial to note the significance of these differing denominators. Let's explore an example that reflects this concept. Alright, our initial scenario involves 5/6 minus 3/4. Let's remember how to do this. Just like adding fractional numbers with different denominators. We use the reduction of fractional numbers to the same denominator. That is, in order to add or subtract fractional numbers with different denominators, we must first bring them to a common denominator. You already know how to bring them to a common denominator. But in order not to get confused and not to make a mistake, we will write down what the common denominator equals. I'll write that down at the bottom of this example. So the least common multiple for the numbers 6 and 4. Let's think about what that number is. I'm not going to write down the steps that will help us bring these fractions to a common denominator, but I'm going to write that down right away in the example. This should and can be done immediately when calculating this example. So, the least common multiple of 6 and 4. Let's remember how to do it. We're not going to write it down, we're going to count it. So, the greatest common multiple of 6. Check. Does 6 divide by 6? It does. Does 6 divide by 4? No, it doesn't. Then I multiply 6 times 2. That's 6 times 2. That's 12. Let's memorize that number. 12, check it. Is 12 divisible by 6? Yes, it does. 12 is divisible by 4. Yes, it does. Then the common denominator or common multiple is 12. Notice it will be the least common multiple. I told you that it is desirable that it is the smallest common multiple. So, let's continue with our next steps. 12 I divide by 6. 12 I divide by 6, that's 2. I write it down as an additional multiplication. 12 I divide by 4, that's 3, and I'll write that down. For the second fraction. Next, now I need to bring it to a common denominator. I multiply 2 by 5, that will be 10. And 2 times 6, that would be 12. Minus 3 times 3, that's 9. And 3 times 4, that would be 12. Notice the denominators we obtained. They are identical denominators, so I will record this common denominator. I am correcting it by subtracting the second fraction from the first fraction. The numerator of the second fraction is subtracted from the numerator of the first fraction, resulting in the numerator 1. Now, let's count. The difference between 10 and 9 is 1. Next, let's rewrite the denominators. We have 12 of them. The final answer is the fraction 1/12. Therefore, the difference between 5/6 and 3/4 is 1/12. Now, let's move on to another example. It's slightly more complex, but don't worry, we can solve it as well. So, here's the second example. Our task is to subtract the fraction 5/24 from 7/16. Although our numbers have grown larger and more intricate, the underlying algorithm remains unchanged. Consequently, I must once again ascertain the least common multiple. Specifically, I am seeking the least common multiple for the numbers 16 and 24. Given their increased magnitude, it is prudent to document the process. Upon noting that the larger of the two numbers is 24, I proceed to verify if it is divisible by 16. Regrettably, it is not. As a result, I multiply 24 by 2, yielding 48. Next, I evaluate the divisibility of this number. Astonishingly, 48 is indeed divisible by 16. Moreover, it is also divisible by 24. Once we confirm this, it becomes necessary to document additional multipliers. This entails discovering a number that is divisible by both 16 and 24. To accomplish this, I write down the number 48. Consequently, I divide 48 by 16, which produces 3. Remarkably, 3 is also divisibly by 16. Furthermore, dividing 48 by 24 gives us a quotient of 2. With this information, it is now possible to achieve a common denominator. By multiplying 3 by 7, we obtain a sum of 21. Additionally, by multiplying 3 and 16, we arrive at the product that is 48 minus 2 I multiply by 5, that's 10, and 2 I multiply by 24, that's 48. And you'll notice that I have achieved equal denominators. When the denominators are equal, I make a note of the denominator and proceed to subtract the numerators. The subtraction would be 21 minus 10. Now I will write down the result, which happens to be a fraction expressed as 11 over 48ths. But before you write down 11/48ths as the final answer, check to see if you can reduce it or if you can isolate the whole part. No, there's nothing that can be done, so that's how I leave 11/48ths. In the next lesson, guys, you and I will add 3 fractional numbers with different denominators. And today our lesson has come to an end. Goodbye, see you.